Today, the topic of discussion is on strength of material, that is PCME 403, Module 2, Part 1. Myself, Dr. Suman Das, HOD, Department of Mechanical Engineering, Swami Vivekananda Institute of Science and Technology. In this video, I will discuss the shear force and bending moment and its diagram. Now, before going to discuss the shear force and bending moment, we have to know the different types of beams and their definition, supports and loads. Now, what is beam? Beam is a structural element which is subjected to load transverse to its axis. In general, beam is either free from any axial force or its effect is negligible. Now, beam is considered horizontal and the load is vertical. So usually or in general, beam is considered as horizontal and the load vertical. Now the types of supports and the beams. So here I will discuss and show the different types of beams and their support. So a beam may have the following kinds of support. First one, number one, that is the roller support. If you see the diagram of the roller support looks like this. This is also the roller support. The roller support, that is the reaction force, that is R is the reaction force that is vertically up, that is the pointed. Hinge support. So this is the hinge support. So in the hinge support there are two reaction forces. One is the horizontal, another one is the vertical. So the diagram of the hinge support looks like this. And next one is the fixed or encasted or built-in support. So in the case of fixed support, so there is one reaction force and one moment is there. Okay, this is the diagram of fixed support. Now, depending on the types of support, the beams are classified as follows. Number one, that is the simply supported beam. So simply supported beam looks like this. So this is the hinge support and this another end is the roller support. So in the case of hinge support, already I mentioned, so one is the horizontal reaction, another one is the vertical. H for horizontal, R for there is the reaction, that is the vertically up. Similarly, here R is the only the vertical because this end is roller support. So the simply supported beam also looks like this. This is the diagram of the simply supported beam. Now the cantilever beam. So the cantilever beam, so one end is fixed, another end is free. W is the load on the cantilever beam and this is the moment. In the fixed end, one moment is there and another is reaction force. Now this is the fixed beam or built-in beam. So both end of the beams are fixed. So one reaction force is vertically up because the load is coming vertically down, and there will be two moments at the two fixed ends. Now this is the prop cantilever beam. So prop cantilever, that is one prop, that is one support is at the free end, and in the fixed end, this is the fixed end. The fixed end only the reaction force is there, and the free end there is a support. Obviously that should be acting as a reaction. Reaction force is also here, and the load is coming from the vertically from the top. Number 5, that is the continuous beam. So continuous beam, more than one support. So this is the support, this one support, this one support, this one support, and load is coming from the top. So in the case of continuous beam, the support is more than 2. Now overhanging beam. So overhanging beam is nothing but the combination of simply supported and cantilever. So this is the part of cantilever and this is the part of simply supported. So BC is the simply supported portion and so this part, that is the cantilever part. So this is both sided overhanged. So A and A, this is the distance, and B to C, the distance is 2B. So this is both sided overhanging beam. So this portion is the overhanging and this is the overhanging part, and there are 2 point loads at the two ends. Now shear force. That shear force is, the symbol is V. Now the shear force is the unbalanced vertical force on one side to the left or right of a section of a beam, and is the sum of the all normal forces on one side of the beam. It also represents the tendency of either portion of the beam to slide or shear laterally relative to the other. Remember that a force of a section means a force of a certain magnitude acting at the point where the shear force at a section means the sum of all the forces on one side of the section. So shear force is nothing but the algebraic summation of all the unbalanced vertical forces left or right of the section. So if you take a section, so here the x-axis is the section. If you consider the left hand part, so that is the W1, W2, W3, that is coming from the vertically downward. So the tendency of the sliding is from vertical to um, from up to down. So the sum of the all the forces is the nothing but the shear force, that is the unbalanced force. So if you take consider this portion only, so in this portion the shear force is the summation of all these vertical unbalanced forces. Now the bending moment. Bending moment at a section of a beam is defined as the algebraic sum of the moments about the section of all the forces on one side of the section. If you consider this section, so left or right of the section, so from this point to this force, from this point to this force, from this point to this force, so sum of the all the moment. So obviously there is a distance, obviously there is a distance, obviously there is a distance. So force into distance, force into distance, force into distance. So sum of the all the moment is nothing but the bending moment. So this is the algebraic sum of all the moment about that section. Now the sign convention of shear force. Notation and sign convention of shear force and bending moment. First of all, the shear force, the sign convention. Which one is the positive shear force? A shear force having a downward direction to the right hand side of the section or upward to the left hand side of the section will be taken as positive. It is the usual sign convention to be followed for the shear force. So if you consider this, that is the section and this is the upward direction, this is the upward direction. So the upward direction shear force which is on the left hand of the section XX is positive shear force. So this type of convention is a positive. Similarly, with respect to the section, the downward direction shear force which is on the right hand of the section XX is positive shear force. Positive shear force. That means with respect to the section, if the tendency of their right hand part is sliding downward, or with respect to the section, if the tendency of the sliding of the left part is upward, this type of shear force is considered as positive shear force. Similarly, the negative shear force, so this is the negative shear force, that is the shear force having an upward direction to the right hand side of the section or downward to the left hand of the section will be considered as negative. So this is the section, and if the left hand part sliding downward with respect to right, or in the other words, if the right hand part of the beam with respect to the section is sliding upward, that is called negative shear force. So this is the sign convention of negative and as well as the positive shear force. Now the bending moment, positive bending moment. Positive bending moment, if we consider, so a bending moment causing the concavity upward will be taken as positive and called as the sagging moment. So this is the sagging moment diagram. So the concavity upward, so this type of moment. So this is the, if you see the diagram, this is the moment and this one moment, and the concavity of the beam, it looks like this, that is called the sagging moment. So that is looks like this. So this is the sagging. A bending moment causing the concavity upward will be taken as positive and called as sagging bending moment. Now negative bending moment. Negative bending moment. So if the bending moment of the left hand section, that is XX anti-clockwise. So this is the anti-clockwise. So right hand part, that is also clockwise. If the bending moment of the right hand of the section xx, if this xx is the section and this is the right hand part, and it is the clockwise, then the negative bending moment. So this type of bending moment is called the hogging moment. So if you see the diagram, the hogging moment is looks like this. So this is the hogging moment. So that is the concavity upward concavity, that is called the hogging bending moment, and that is the negative bending moment. Now, in the case of simply supported beam with a concentrated load P not at the midspan. So, if you see the diagram, this is a simply supported beam and P is a concentrated load. Total length of the beam is L and A and B. A is greater than B. From the diagram, it is very clear. Now, considering the equilibrium, that is the RA, so with the help of the moment, we have to calculate the value of RA and also the RB. Taking moment at point A, we will get the value of RB, and taking moment at point B, we will get the value of RA. So RA and RB can easily be calculated with the help of the moment equation. Now, the shear force and bending moment diagram, how to draw. So take a section between A to the point of application of the load P. Now consider any cross section XX. This is the any cross section XX which is at the distance X from the left end, and another section YY. This is the YY. If you see the diagram, at a distance X from the end A as shown in the picture. So this is the another section, that is YY, taking a distance X, and this is the XX section. So that distance is also, this is also X. Now, shear force, that is the range. So, first X, the range is greater than 0 and less than A. So, this is the range of X. So, X is greater than 0 and less than A. So, this is the range of X. So, in that case, if you take any section, in that case, the RA, that is the result, that is the reaction force, that is PB by L. So, that is the Vx. So here and the left hand part of the section, so the unbalanced force is Pb by L. So that will be valid just before point P. So that is the this constant value, that is Pb by L. Now in the range of next one, that is the when you take a section, that is the YY. So X greater than A, less than L, that means in between the range, but we are considering, we are taking the distance from point A. So Vx, that is the shear force at this point, is nothing but, so there is a force P and there is another force, that is the Ra. So Ra is Ra. So Ra minus P. So if you just put the value of Ra, so Pb by L minus P. So we are getting the value of minus Pa by L. That is constant. From this portion to this portion, that is constant. That is the value of negative value. Now, if we go for that that, so there is the bending moment now. So if you see the diagram, so in the case of bending moment, same thing in the range of x greater than 0 less than a. So that is x greater than 0 less than a. So mx should be, so taking that distance, force into distance. So this is the force and this is the distance, pb by l into x. And if we put the value of x, in that case we are getting the value of mx equals to 0, x equals to a, mx equals to PAB by L. So that value is maximum. In the same way, in between the range x greater than a less than L, x greater than a less than L, so we are taking this section. So we are going to calculate the bending moment at this section. So mx, so nothing but force into distance, force into distance. We just, this is the equation. Now we just put the value at b equals to this, and we are getting this value. Now at x equals to a, we are getting the value of mx. At x equals to l, we are getting the value of this, mx equals to 0. Okay. So at the 2 point, that means two distances x, and this is the xx and yy, we can easily calculate the value of bending moment, and also from our previous discussion, also the shear force. Now this is the complete diagram of shear force and as well as the bending moment. From this portion to this portion, the value of shear force is constant, and exactly at this point P, that is the value of shear force, that is this one is P, and again that is the negative, and that will be continued negative form, that is minus PA by L, and this is the value of bending moment. Okay, minus plus PA B by L, that is the highest point. Now, a simply supported beam with two concentrated load P from a distance A from both them. So, same phenomena. So, if a two concentrated load is acting at in a simply supported beam, a distance A1, and this is also A and this is also A, what should be the diagram of shear force and bending moment? So, the diagram of shear force and bending moment should be like this. So, this is the value of shear force, and from A to C, the value of shear force is constant, that is positive. Similarly, from D to the up to the NB, that is the also constant, that is minus P. And the calculation is same, the procedure is same. You have to take section, and the left hand part of the section, what should be the value of shear force, that is the algebraic summation of the shear force. Similarly, at any section you have to consider, and the diagram are easily calculate the value of shear force, and you can easily draw the value of the shear force diagram. Similarly, the bending moment diagram should be like this. So this is the shear force diagram, and this is the bending moment diagram. Thank you. Thank you very much.